Hello, everyone. Let's compute this problem without using the multiplication, without using this long multiplication here. So it's going to be terrible. Let's just try to start by doing that and see what's going on. So 7 times 7 is 49, 7 times 7 is 49, 7 times 7 is 49. And then you're going to get the 0, 0, 0, 0, 0, 0, and then 49 again. And then, okay, so it's too much trouble, right? Forget it, right? So let me just erase that. Okay, now we can actually use some of the properties for real numbers. Then we can actually calculate this without using the long multiplication. Okay, so how do we do that? First, we recognize that this is actually the difference of two squares, so we can factor this. And how do we factor it? You can factor that as 70,707 plus 40,404, and then that sum times the difference, right? The difference of 70,707. Okay, and then minus the 40404. Okay, so how's that? And then now calculating those would be easy because you're just adding the 7 and 4, and then because if you can see here the tens digits are both 0, so even though 7 plus 4 will give you 11, and then you all you need to do is to just to write 1 and 1, and then the same thing will start repeating, right? Okay, so from there we are going to get 1 1 1 1 1 1, right? Yeah. How do we get that? The 7 plus 4, we get a 1 here, 11, with the replacing the tens place with a 1. And then 7 plus 4, another 11, right? And then 7 plus 4, another 11 here. So we put them together. What about this one? This one subtraction is even easier because we don't need to do any borrowing or carrying, right? So you're just going to get this times, what is that? That's 3, 0, 3, 0, 3. Okay. Now at this point, you may feel like, okay, so we still gotta do long multiplication, but let's try not to do that, right? What can we do here? First, I'm going to multiply this expression by 9. Then I'm going to get, let's just try to multiply by 9 right here. So what am I doing? Of course, we cannot just multiply by 9 because that will be changing the problem. So what we need to do is that we are going to multiply by 9. And then to not change our problem, we need to multiply by its reciprocal so that you are not changing the problem. We are basically multiplying by 1 here, that we are still having our original value. And so what we need to do is that we are going to take this 1, 1, 1, 1, 1, 1, 1, 1. Wait, how many ones are there? 1, 2, 3, 4, 5, 6, right? We multiply this number by this 9, then we are going to get what? We are going to get 99999. Let me see if that's correct. That's yeah, so there are 6 9s in there. And then we can actually take this we can actually take this the 30,303 and then multiply by this 1 over 9 here. We can actually just cancel, right? So we can just cancel that and just do some canceling. What can we do here? What we can do is that we can do this 9 becomes a 3, and then this one becomes 10101. So we are getting a nice number, right? Okay, so we get 10101. Okay, so at this point, it feels like we still need to do the long multiplication. Still just going to be terrible. It feels like it's worse than before. But here, we can actually turn this 999,999 into 1 million minus 1. So we have 1 million. That's 6 zeros with the 1, right? Minus 1. And then times this 10101. And then, oh, I forgot the 1 over 3 right here that I still need to put it there, right? So we're still at 1 over 3. That's why it looks strange when I was doing that step. Okay, yeah, so that 1 over 3 must stay there. Okay, so this one 10101. I should just keep the same color. Okay. And then now you may say, what do we do next? We can use the distributed property, take this 1 million, multiply by 10,101, and then minus 1 times the 10,101, right? And then let's just forget about the 1 over 3 at this point. Okay, so we are going to get, and when you multiply any number by a million, you are just going to add 6 trailing zeros to that number. So we are actually going to get this this 10101 and then 6 trailing zeros. So 1, 2, 3, 4, 5, 6, and then minus this 10101, right? Because 1 times anything is that thing, right? So you just the same number. And then of course we need parentheses. And then times the 1/3. And then at this point, you can see that we can actually distribute the 1/3 to those two numbers. And yeah, so both numbers are divisible by 3. So before I do any subtraction, I could have just divide by 3 first because the division is actually easy. So we avoided doing the long multiplication, but we actually need to do the long division. But actually, it turns out that the long division is not too bad. So I'm just going to do the long division on the side and then we'll come back to the problem. So I'm just going to take the 10,101 and then I divide by the 3. So that will be easy here. 3 times 3 is 9. Then I subtract the 1. I'm going to get 111. So 3 times 3 is 9. And then you are going to get the what? 20. 20. And then 3 times 6 is 18. So we are going to get the 21 here. And then you are going to get the 7. And you may ask, why don't I just subtract them and then divide by 3? But think about this. Those two numbers, they're actually the same thing. When you do long division, you actually don't need to worry about the trailing zeros. You can actually just add the trailing zeros to attach the trailing zeros to your result. So both numbers they look really almost the same thing, right? Except that this number right here, this first number has 6 trailing zeros. Okay, so yeah, I didn't finish writing that long division down, but it actually doesn't matter here. And I don't need that anymore. I can erase all that right here because we did that calculation. So the answer will be 3,367 when you take those two numbers, divide by 3, except that this one has trailing zeros. Okay, so let's continue going back to the problem. We are going to get what? We are going to get 3,367, and then we have 6 trailing zeros, and then minus, and then 3,367. Okay, now we don't need to set up the vertical subtraction to subtract them here. Actually, just make the easy calculation because you need to do a lot of borrowings with the zeros, right? It's a lot of trouble. So what we can do is that we just take away 1 from this number, which is what 1 less than this number is 3,366, and then all those zeros will turn into a 9. And then now you subtract them. And then, of course, we change this number, right? We change this number to a number that's 1 less than the original number. So we need to add that 1 back. So adding the 1 back, then we are not changing the problem. Right now, don't worry about the 1. Let's just subtract. Subtraction is easy in this case because you don't need to do any borrowing anymore. So you do the 9 minus a 7, right? Actually, there is no borrowing, so we can actually just start from just writing down the answer. So 3,366. Oh, actually, it's 6, right? And then 9 and 9. And then now regarding those last 4 digits right here, because that's what we are trying to calculate here. Take those 9,999 and then subtract this 3,367, which will give us, okay, so I'm just highlighting the color for the calculation here. It's going to be 6, and 6, and then 3, and 3. And then, of course, there was still the plus 1 right there, but adding 1, we all know how to do it, right? So that's no problem. Oh, actually, that's not 3, that's a 2, right? Because 9 minus 7 is a 2. And When you add the 1 back, then it will become a 3. So our final answer will be 336699663, and then we're done with the problem. Okay, so no long calculation, or we don't need to do any long calculation. It's just using a lot of different small tricks that will help us to do the arithmetics. The longest one is really just this one, but it's not even that terrible. So that's why I didn't do the subtraction in the beginning, because after we do the subtraction, I could have used this trick to do the subtraction, but then after that, when I divide by 3, I need to do the long division, and it's more complicated for that long division. If you're using just a bunch of small numbers and then divide them, it will be easy. Okay, so that's it for this problem. If you like this kind of videos, please subscribe to my channel. I will do more. I will try to make more problems that will look like this, or will show you nice tricks. Okay, so yeah, please subscribe to my channel. Thank you for your support, and I will see you next time.